So in this example, we have two given events for an experiment. We just called them A and B. We know the probability of A is 0.63, the probability of B is 0.45, and the probability that A and B both occur together is 0.10. So we want to answer the following conditional probabilities, but kind of before I get started, one of my recommendations is whenever you have given information, write it in terms of the probability notation so that you know what you're already dealing with. As you tackle these problems, you'll see that maybe you won't need any fancy tricks to get the answer because that information is already there. So the probability A is 0.63, the probability of B is 0.45, and the probability of A and B is A intersect B. That both events occur was 0.10. So when we look at the first one, all we need is the definition of conditional probability. And I'm not going to put it in terms of A's and B's so we don't get confused here. So I'm going to say the probability of the event E, given that the event F has occurred, is the probability that E and F occurs over the probability of the given, so the probability of F. So now when I look at the first question, for A here, the probability of A given B, when I write out the definition, I realize I've already got the values to put into the formula. So the probability A given B is the probability of the intersection of A and B divided by the probability of the given. And so remember, this says A given that the event B has occurred. So given B here. Probability of intersection is 0.1. Probability B was 0.45. And if you want, you can simplify this. This is 10 over 45. And since 5 divides both of those, you can write it as 2/9. B is very similar. We just have to use the definition. Now I'm looking at the probability of the event B occurs given that A has already occurred. So B given A is the probability of the intersection again. And the nice thing about the intersection, it doesn't matter if I say A and B or if I say B and A. It's the same overlap region in a Venn diagram. So we know that the order in which I write the intersection of two events does not matter. So we have the probability of B and A on top, which is again 0.1. Probability of A is 0.63. And so we have 10/63. And that doesn't simplify, so we can leave it alone. Just kind of a side note, when I look at these two, they don't equal to each other. So it's a bad equal sign, but I kind of draw arrows here. They're not the same. So whatever is given changes that sample space into something completely different. And so if I look at the probability A given B versus probability B given A, we're looking at different outcomes in the experiment for what was given. And so we shouldn't expect these to have the same probabilities. Alright, so to continue on, part C, I'm going to show you that we can solve this in two ways if we think about it correctly. I'm just going to go straight to the definition and show you what happens, then I'll kind of show you a little bit of a shortcut. So when I go to the definition here, this is the first one where, I write out the definition. I take the intersection of these. Remember, this says A complement given B. So I need A complement intersected with the event B, and I'm dividing by the probability of B. Well, that denominator, no problem. We already know probability of B is 0.45, but we don't have A complement intersect B. So when you run across, this is now an unconditional probability problem, sometimes it's nice just to go back to Venn diagrams to figure out, well, what is this probability based on the area in the Venn diagram. So I'm going to construct a Venn diagram for this example. So in my picture, trying to leave those probabilities up there, I have A, I have B. Now all of A is 0.63, so I know these two areas add up to 0.63. But the inside piece where A and B overlap, that region right here, that's 0.10. So I'm going to fill that in. I know this is 0.10. But all of A is 0.63, so this has to be 0.53. And remember, when I look at probability of A is 0.63, it's not just this one region, it's both regions when I add them together that make up all of A. Same thing's true for all of B. When I look at all of B here, I know 0.1 is laying here. All of this has to add up to 0.45, so I'm forced for this to be 0.35. We may need this exterior at some point, so if I look at the probability of each of the areas and add them together, that should equal to 1 to give us that 100% of all the area being covered. So I have 0.53 plus 0.1, that's 0.63, 0.63 plus 0.35 is 0.98, so this area here is 0.02. Now I can look at my A complement intersect with B. So I'm trying to figure out what this region looks like. Now I've got the advantage of two colors, so I want the intersection of the complement of A with B, and if you can do that in your head visually, that's great. So I'm going to put A complement as this orange and kind of shade that in. So that means everything that's outside of A. So there's this little piece that's inside B, but it does not include this inside region. Now B complement, I'm going to make purple. Sorry, B, I'm going to make purple. So when I shade in B, the intersection represents where both of those are combined. So where I have the purple and the orange is this region right here that I shaded in black. And we see that in my Venn diagram that this black region has a probability of 0.35. So I know the probability of A complement intersect B is 0.35. And so simplifying my fraction here for the probability of A complement given B, 35/45, or 5 divides both of these, I have 7/9. Now I said I'm going to show you another way. Remember what the complement rule is. It says that the probability of the complement is 1 minus the probability of the original event. So when I look at probability of A complement given B, the given just tells me what my new universe is. So I'm not worried about what this is. The complement rule just applies to the event. So remember, this is the event of interest. So when I apply the complement rule, I just change this from the complement to the event itself, but I'm still inside of B. So I'm still given that B has occurred, but I'm applying the complement rule to the event itself. So the key here is that you don't change any of that given information. So now if I want to answer this question, probability of A complement given B, I just need to take 1 minus probability of A given B, and remember we solved that. A given B, probability was 2/9. 1 minus 2/9 is 7/9. That's the same thing that we got by just using the definition in our Venn diagram. So sometimes it's helpful to recall all of those different rules for probabilities, because sometimes you may need to do this procedure using Venn diagrams to get the answer, but other times if you look at some of the questions, you might be able to apply a complement rule to answer them more quickly. Alright, the next one, D, probability of B given A complement. So this one's interesting because I want to show you that the complement rule can't be applied to that given piece. So the complement rule, if I had to use it, if I tried doing the same trick that we did earlier, it would say that this is the probability of B given A complement, 1 minus the probability of, now take the complement of the event, so this is B, so that's going to be B complement, but we're still inside of that given region, we're still inside that A complement region. And so this doesn't look like any easier to solve than my original problem because I don't have that information. So I'm going to go back just to the definition to try to answer this question of probability of B given A complement. And I may have to refer back up to this Venn diagram that we created earlier. So back to just my formal definition, because that's all I have to really tackle this one since my complement rule failed to give me anything easier to work with. So the probability of the intersection of B and A complement over the probability of A complement. The denominator, I can use the complement rule to find that answer, 1 minus the probability of A. The numerator, I need to figure out, what is B and A complement look like in my Venn diagram. So I have A, I have B. So I'm going to shade in B green. And since I'm taking the intersection, I'm looking for where they overlap. A complement is in red. I realize I'm left with this area inside of B again. And that area was 0.35. And again, we're getting that from the Venn diagram. Now, if you had noticed in our previous work that we already found the probability of A complement and B, you could have just used that answer of 0.35. I just wanted to show you what the method is. If that's not one of the pieces of information originally started with, we can look at a Venn diagram to find what region's shaded in. And since we plugged in all the values in the Venn diagram back up here, I just pulled off the probability that was that shaded in part. The denominator, we said, just use the probability of A. Probability of A, sorry for the scrolling, but probability of A here was 0.63. So I have 1 minus 0.63 in the denominator. So my probability of B given A complement is 0.35 over 0.37, 35/37. Now for the last question here, find the probability of A complement given B complement. If you try the complement rule on this one, why don't you pause the video and do it, see if it's going to make it shorter. You're going to see that it doesn't give you anything easier to solve because you don't have the probability of A given B complement. So when you're using the complement rule, you take the complement of the event and see, do I have that information to help me solve it? In this case, no, we don't have A given B complement. What we had was our last one, B given A complement. Since that's not related to it, there's not much the complement rule is going to do to help me solve this. So I'm just going to use the definition. I need the intersection of A complement and B complement over the probability of B complement. I know the denominator. I can use the complement rule to find the probability of B complement. The intersection, again, we've got our Venn diagram as a tool to figure out, well, what is that probability? If I look at the complement of A intersected with the complement of B, what region is that in my Venn diagram? So A complement is going to be in green, so that's everything outside A circle. B complement I'm going to put in orange, so everything out of the circle for B. And since we're talking about the intersection, I'm looking for where those two regions overlapped. So where the orange and green are together, it's outside the circles and nowhere else. So this probability is this outer region of my Venn diagram. And so if we go back here to my Venn diagram we set up, we see that the outer region is 0.02. So I have 0.02 here, A complement given B complement is 0.02 over 1 minus 0.45, which gives us an answer of 0.02 over 0.55 or 2/55.